Here's an example of a solve by elimination systems question. Now, before I launch right into doing this, there are a few things that I want to make sure that you know that you have to do. The first thing is make sure that you line up your x values, line up your y values, then line up your constants. Usually the problem will have x's first, then the y's, and then an equal sign, and then whatever numbers. It doesn't always have to be the case. Your numbers could be listed first, your y's could be listed first, it doesn't matter. But just make sure when you're doing elimination that you move the values around so x is lined up, y is lined up, and then the numbers are lined up. And make sure you keep the signs if you're going to move things around. In order to do elimination, you're looking for something that I describe as opposite coefficients. What I mean by that is, if you look at the coefficients on x, well, that's 1x, so your coefficients on x are 1 and 3. Those are not opposite numbers because they're both positive, and also they're not the same number. One is a 1 and one's a 3. In order to be an opposite coefficient, you'd look for something like 1 and -1, or 2 and -2, or 3 and -3, so on and so forth. Those would all be pairs of opposite coefficients. We like pairs of opposite coefficients because when you combine them, 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0. So they would all eliminate. And that's kind of what we're looking for when we're doing an elimination question. We are looking for a pair of opposite coefficients that when we combine them with addition, they will eliminate. Now, since we have everything lined up here, we can almost treat this as like 3 different little addition questions. So if you look at this, and this is how you're going to do elimination each time, this is important why you line up the x's, the y's, and the numbers, because you're going to add down the columns. Now, 1x plus 3x, that'll give you 4x. Positive 2 plus a -2 is going to give you 0, so the y is eliminated. Carry down your equal sign, and then 7 plus -3, that will give you 4. The beauty of elimination is that when you have a pair of opposite coefficients, like we did right here, you had 2 and -2, when you combine down the columns, that variable is going to go away. 2y plus -2y, or 2y minus 2y is 0, so it's gone. Now we have a one-step equation. All we have to do is divide each of these sides by 4, and we get our x value of 1. Since this is a system, we're still looking for an ordered pair as an answer. And now we just have to take our x value of 1 and we need to plug it into one of the original equations, either this one or this one. It really doesn't matter, since they're both not isolated for x anyway. Just pick one of them. We'll use the top one. So we'll use x plus 2y equals 7. We solved x for 1, so it's 1 plus 2y equals 7. Now it's just a two-step equation. Subtract 1 from each side. You have 2y equals 6. Divide by 2, y is going to be equal to 3. And there you have it. There is your answer, 1, 3. Again, this is different than substitution, but you're still doing the same thing. You're still looking for an intersection point of where these two things would meet. When you're doing elimination, make sure you have the columns lined up with variables that are like, as in x or y. Then make sure you have the numbers lined up. So when you add them down, you're adding like terms.